Hello friends, I am Saroj Vishwas, gold medalist, first rank holder of 1994 batch in engineering stream of all the colleges affiliated to University of Mysore during that period. A BE in civil engineering from National Institute of Engineering Mysore, a MTech in structural engineering from Indian Institute of Technology, Delhi, that is IIT Delhi, a Sun certified Java programmer, Sun Microsystem USA. I have more than 25 years of professional experience in designing building structures and allied subsidiaries. I invite you all to learn with me how to design building structures using commercially available structural softwares with the help of some manual computation as and when needed. For today's lesson, we shall learn how to provide the structural GA data to a detailer so that he or she may be able to prepare the structural GA which shall be further used for to generate the production drawing, that is called the fabrication drawing. The very first thing we should provide in structural GA is the anchor board layout. Now to provide the anchor board layout, we first know the layout of the anchor board. For that we need to go back to our architectural drawing. This was our architectural drawing at ground floor level. Now let us take this floor plan to Excel file. Actually we should use A3 size of paper and draw this grid. That will be faster to provide the data. But when you require to provide this data to a detailer who is sitting on far side, say at other station, so you might have to take help of paint or Excel kind of things. So but in an office environment, using a A3 sheet or A4 sheet to provide the data will be faster. And in today's life, if faster work is always demanded. So let us take this file to Excel file. So I am taking this with the help of a snipping tool. So now edit, copy. Let us go to open a blank Excel file and paste it there. This is a blank Excel file which we have opened. Now Control V. So our grid layout is prepared. Now we shall go one by one providing the grid data. The detailer may provide the base plate name as per his convenience. Which we will provide the detail as per grid. So we can write here grid 1A, 1B, 1D, 3A, and 3D. All these 4 base plates have shall have same dimension, because if you remember we have same column sizes. Here you could see the properties R10. So these 4 columns are of higher length. So we have same 1, 2, 3, 4. We will have same base plate for these columns. So This is our grid. Now let us go to the base plate detail we have designed for this grid. The spreadsheet we have designed for this grid. So this is our base plate detail which was designed for these columns. How to design this base plate has been already explained in a earlier tutorial. So you can see the base plate size is 375 by 520. Our number of boards on one side is 8 boards, and the sizes of the boards are 16 mm dia. And if you look for the embedment, length required is only 75 mm, but in usual cases in nominal embedment of 250 mm is always provided. Now if you go to the thickness, check the thickness of the base plate, it was taken as 20 mm. So we have the data. Our data is 520 into 375 into 20 thick base plate with 16 number of 16 dia board with embedment of 250 mm inside the concrete. Along with this, we should also provide the data for the column that will come along with this base plate. So let us go back to the STAAD file and see what is the column size. So our column size was 300 by 5 on 150 by 8. 300 by 5 and 150 by 8. So let us go back to the Excel file again. So let us draw a I section. This can be drawn with the help of a hand sketch when it is available when we are doing it on a sheet, A3 sheet. So this is our I column, and now let us draw a rectangular over this. Format it, shape fill, no fill. Now along with this, we should also provide the stiffener thickness. If you see the design detail, the stiffeners are taken as 20 mm with 85 mm, 125 mm height, 85 mm width and 20 mm. So that should be also noted down. Now we have 3 such stiffeners that should be also drawn. 1, 2, 3, 4 on the other side also. Now there should be one more plate of same thickness of the stiffener that should extend up to the width of the base plate. Let us draw that also. So now we have to draw the anchor bolts positions also. So let us take a circle shape. Let us fill that with red color. Copy. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is our base plate configuration. Now we need to write the details also. So this is a 520 thick. So the base plate is BP DP 520 into 375 into 20 thick. Then 16 numbers of 16 dia anchor bolt. Then stiffener equal to 125 H into 85 B into 12 T. Then next one more thing is also there. Embedment of AB is equal to 250 mm. So from this the detailer can decide which anchor bolt he should select from the available set of anchor bolt provided by the factory or whatever it is available in the market. So according to that he will provide the length in the drawing. So this is our base plate detail at grid 1A, 1D, 3A and 3D. Now let us draw the base plate detail at grid 1B and 3B, then 1C and 3C. Checking from the Excel file or a spreadsheet we have designed for these columns, we will have the following data. So this is our data for base plate at grid 1B, 1C, 3B, 3C. Now we also need to supply the size of the column so that the draftman detailer is able to draw it properly. So this column was 300 by 5 and then flange is 150 by 8. Our columns at grid 1B, 1C, 3B, 3C was wave 350 by 5, flange 175 by 10. In a similar manner, we should provide the detail for the columns at grid 2A, 2B and 2C. So this will be our data for base plate at grid 2A, that is at intersection of grid 2 and grid A, and there is a 350 by 5 and 175 by 10 column, and again at grid 2B and grid 2C there is a 300 by 5 and 150 by 10 column. Our last column left is the column at grid 2D. Now this is a column which has a hinge base, so it will be a different kind of detailing for with respect to the column base plate we have provided for this 4 number of pieces. So going back to the Excel file, how we have designed this in place, we will have this kind of configuration. So this will be our base plate detail with a column which has a hinged or pin base. So the base plate size is actually 160 mm and 12 thick base plate. Now you may see at times, if you see at the Excel sheet of the base plate, at this part we have considered the bending stress, plate bending stress. Now at times this plate bending stress could be huge, so at that time we might consider to provide a stiffener plate at mid span or at appropriate angle and provide a anchor bolt at these positions. Suppose this is the I column, so this is the I column, this is a stiffener, this is a stiffener, so this is a stiffener. So using these stiffener plates we can reduce. Now for a base plate designed for with that is having movement, you will see is that if you look, the base plate stress distribution always remains constant. The compressive stress is always almost uniform. So by providing this kind of analysis which we have used in the Excel, most of the time we will get similar thickness of the base plate. But at times when the base plate movement is not much, providing taking this kind of compressive stress with plasticity of concrete may not be economical. So if you see AIC code, there is a triangular distribution also provided. So if there is no tension at all, no tension is created, only compression is created, so we should not use this maximum part. We should instead use this triangular distribution and compute the bending moment, so that our base plate thickness can be economical. So with this we complete the base plate details to be provided to the structural GA detailer. We will be able to draw the base plate details along with the steel lines and other lines with this information. So when you join a firm, they might have a different kind of format to provide this data, but it remains more or less similar like this only. So there could be some difference in writing the information, but the information is similar to this only.